So, good afternoon, students. Today, we will discuss applications of the solar energy. Now, this application may be classified into three categories. One is direct thermal application. Second is solar electrical application. Direct thermal application. Then second is solar electric application. And third is other category. So these are three classification of the solar energy. First is direct thermal application. Now, direct thermal application make direct use of the heat resulting from the absorption of the solar radiation for space heating and cooling of some building, or to provide hot water service for such building and supply heat for agriculture, industrial and other processes that required only moderate temperature. So some applications are there. Some applications are there where we need direct radiation from the sun. Where we need direct radiation from the sun. That means I'm just taking that example of the. Let us take one example of the building which is required to be heat up, and that heating may be with the help of some solar radiation, or another application is either we want to heat we want to increase the temperature of the water with the help of solar radiation. That is again the direct application of the solar energy, right? Another is for agriculture purpose. Let us say we want to just provide some nominal temperature across some agricultural product. That will be also considered as a direct thermal application. So in this case, we are just taking the example of this. We are just taking the example of heating of the building, or direct heating of the building. Then after that, heating of water, direct heating of the water, and another is for agriculture purpose, agriculture purposes. We need some direct radiation. So this type of the category may be considered as direct thermal application. Now come to the second part. Second part is solar electrical application. Solar electrical applications means where that solar energy is converted directly or indirectly into electrical energy. Here we are just taking that in the second category. This solar energy may be directly converted into the electrical energy, or it may be indirectly converted into the electrical energy. We may consider the both in this category, right? So in this category, we may consider either the direct conversion of direct conversion of solar energy or solar radiation into electrical energy, or here in the same category we may consider indirect conversion of solar energy indirect conversion of solar energy into electrical energy. Indirect conversion of solar energy into electrical energy. So both of that may be considered as this category solar electrical appliances, solar electrical applications. So in this case, we are having 4 general conversion method. One is we will discuss it one by one. 4 general conversion methods are being investigated. In the second category, that is solar electrical applications. Second category is solar electric application. Solar electric application. In this category, we are having 4 different types of the devices, you may say. So first is this solar thermal method. First one is, we will discuss it one by one. Solar thermal method. So in this solar thermal method, this involves production of the high temperature such as are required to boil the water or other working fluid for operating turbine which drive the electrical generator. These are considered under solar thermal electrical conversion, right? So let us suppose we are just putting some radiations on one boiler, with the help of which we are just increasing the temperature of water, and we are increasing that, or some fluid, we are increasing that temperature at such a high temperature that energy produced from that water or energy produced from that fluid, that will be just used for rotation of the turbine, then that type of the application will be considered as solar thermal electrical application, or this method is known as solar thermal method, right? So second is photovoltaic method. Second method is photovoltaic method. Photovoltaic method. In this method, we use the devices like solar cell to convert solar energy directly into electrical energy without machinery, right? So here in this photovoltaic method, we are using PN junction, right? These are the PN junction may be used. PN junction may be used for conversion of solar radiation. PN junction may be used for conversion of solar radiation into electrical energy. These are special type of the material whose this potential barrier may be break, with the help of solar radiation, right? So in this case, this p-n junction, this is known as solar cell. Solar cell that may be used to convert solar radiation directly into that electrical energy, right? The third is that conversion of solar energy into electrical energy without the use of machinery, by utilizing thermoelectric effect, that is considered as the thermoelectric conversion, right? Third category, that will be thermoelectric conversion. This will be, this part we will just study it in the previous lecture. In that you may take that example of the Seebeck effect, right? And you may also consider that application as a Peltier effect or Thomson effect, right? In each and every case, what will happen? We are just due to that some heat across the junction, we are capable to produce electricity, right? Such as in case of the Seebeck effect, there are two different junctions. One is kept at the high temperature, and second is kept as a cool, that means at a low temperature, and depending upon the temperature difference, between the two junctions, there may be an production of the electricity, right? Or you may say that there is production of the electrical energy. So in this case, various thermoelectrical effect, may be taken into consideration, right? Various thermoelectric effect may be taken into consideration under this category, right? And then in the same category, this photovoltaic method, this solar energy application in the solar electrical appliances, this solar thermal method may be considered. Then this photovoltaic method may be considered. Then after that, this third category may be considered. And fourth is wind energy, is the form of solar energy that can be converted into mechanical energy and hence into electrical energy by the means of generator, right? Again, you may say that this wind energy, if you are aware with the basics of wind, that is also dependent upon the heat. Whenever the temperature of the atmosphere will increase, this will cause for the blow of the wind across the nature or across the atmosphere, right? So these may be considered as this one of the form of the solar energy conversion. First, that solar energy may cause for the blow of the wind, right? Solar energy may be caused for the blow of the wind, and after that, this wind will blow, then this wind will be converted into mechanical energy. That means with the help of that mechanical energy, we are just going to rotate that turbine. And then after that, mechanical energy, with the help of which we are rotating the turbine, that is further coupled with this some of the electrical generator, right? And then that electrical generator may be used to convert that mechanical energy into electrical energy. So this may be another form of the solar electrical appliances. So in case of solar electrical appliances, we may take these four category. In addition to that, there may be ocean thermal energy conversion, right? There may be again ocean, thermal energy conversion, ocean thermal energy conversion. In this case, again, by the use of this depend upon the difference between the solar heated surface water and cold deep ocean water to operate a water expansion turbine, right? And in this case, again, electrical generator may be used to convert that ocean thermal energy into the form of electrical energy. So these are some of the devices which may be taken as a example or as a application for solar electrical applications, right? First category is, we are just dividing the applications of the solar energy into three categories. One is direct thermal application, second is solar electrical application, and the third is energy from the, I am taking it as the other forms of solar energy, that is energy from the biomass and biogas, right? Energy, third category is energy from the biomass and biogas. Energy from the biomass and biogas may be also considered as application of the third category. In the application, energy from biomass and biogas, right? So energy from the biomass and biogas may be considered as another category for this application of the solar energy, right? So energy from the biomass and biogas refer to conversion into clean fuel or other energy related product of the organic matter. Either it will be directly or indirectly. Biomass material include agricultural, forest, animal residues, right? So these may be just used in the presence of the in the presence of the that solar radiation, with the help of which we will be able to convert that biomass or biogas into another form of energy, and that form of energy may be used to rotate the turbine, right? And that turbine will be further coupled with the alternator or generator. Then when that alternator or generator will rotate, when alternator or generator will rotate, this will cause for the production of the electricity. So this is indirect method for the production of the electricity by the use of solar radiation. Biomass or biogas may be used, biomass or biogas may be used to just induce, biomass or biogas may be used to induce electricity, because the energy produced from the biomass or biogas may be utilized to produce some mechanical energy, and this mechanical energy will be further converted into that for the rotation of the turbine or for the rotation of the alternator or generator, and this alternator or generator may be further used for production of the electricity as per Faraday's laws of electromagnetic induction, right? What does that Faraday's laws of electromagnetic induction told? That is, an EMF is induced across the coil whenever there is rate of change of flux. Whenever there is rate of change of flux, and EMF is induced across the coil, right? So depending upon second law states that amount of the EMF induced is directly proportional to the rate of change of flux, right? So depending upon this Faraday's laws of electromagnetic induction, whenever that coil placed in the generator or armature of the DC generator that will rotate, This will cause for the production of the d phi by dt, and due to this some EMF will be induced across the coil, and that may be utilized for just operation of the various domestic as well as industrial appliances. So these are the major category for the application of the solar energy. So solar energy applications may be in main. In main, we may classify this application of the solar energy into three categories. One is this direct energy conversion. Second is solar electrical appliances, and third is this energy from the biomass or and biogas. In the first category, in brief, in the first category, energy from the this solar radiation that will be directly used for the heating of the building, for the heating of the water, for increasing the temperature of some agricultural products, right? So this may be considered as direct application of the this solar energy, direct application of the solar energy. In second category, we will take solar electrical appliances. So in solar electrical appliances, you may consider that photovoltaic cell. Photovoltaic cell means solar cell, right? So solar cell is a simple p-n junction in which some special type of the semiconductor material are used, right? In some special type of the semiconductor material are used, and that material will convert that solar radiation directly into the form of electrical energy. Another category is with the help of this solar radiation, we will be able to generate some wind, right? We will be able to generate some wind, and that wind may be used to just rotate. That wind will be used to rotate the turbine, and this turbine will be further coupled with the generator or alternator, and that is used for the induction of the EMF, right? Another category in the same that is solar direct solar electrical appliances, that is the some solar thermal that effect, right? In that I am taking that example of CVAC effect, or some Thomson effect, right? These effects may be considered, and with the help of these effects, we will be able to convert that solar energy into the form of electrical energy, right? So in solar electrical appliances, we may consider either direct or indirect. Like in case of this photovoltaic cell, we will convert that radiation of the solar energy directly into electrical energy. While if I am taking that example of the wind or ocean, in that particular case, what will happen? We will just convert that solar energy first into mechanical energy, and then that mechanical energy into the form of electrical energy, right? Another of this solar electrical appliances, I am taking that example of the case that with the help of solar radiation, I am just increasing the temperature of some water. I am just increasing the temperature of the water or maybe some fluid, and that increase in temperature will be so high that it may be used for just production of some mechanical energy, right? And that mechanical energy will be further used for the rotation of the turbine, right? And then after that, this mechanical energy will rotate the turbine, and that turbine is further coupled with this some alternator or generator. And due to that, when that turbine will rotate, this will cause for the production of of the d phi by dt, and as per Faraday's laws of electromagnetic induction, an EMF will be induced across the coil, right? That is the second category of the application. Third category is from the biomass or biogas. With the help of biomass or biogas, from the biomass or biogas, that is from the agricultural product forest, like that, we will be just convert that biomass or biogas product, we will use that energy for the production of the this electric mechanical energy, and that mechanical energy used to rotate turbine, and that turbine is again further coupled with the some of the generator or alternator, and that alternator will be used to produce some electrical energy as per Faraday's laws of electromagnetic induction. So all this, this is the basic of the application. Basic of the application. In addition to that, some other form of the solar energy is also there, right? So some other forms of the solar energy is also there. In that, we will consider solar water heating, space cooling, solar energy, that is thermal electrical conversion, solar pumping, or solar furnace, solar cooking, or solar production of the hydrogen, or solar greenhouse. So these may be considered as some other application of the solar energy, right? So now in continuation with the this solar energy, there are some other forms of the solar energy, right? So water power, other than this tidal power, also represent the utilization of the solar energy, right? So fossil fuel, or like coal, oil, natural gas, that may be used for the production of the electricity, right? Now this based on this the above classification, direct solar energy application that may be discussed in these order. One is solar water heating. Direct, I'm talking about direct. First is solar water heating. Then second is solar space heating. Solar space heating. Then solar space cooling. Right. Then after that, another is this solar energy thermal electrical conversion. Solar energy thermal electric conversion. Then another is this solar energy, which will be photovoltaic electric conversion. Solar energy, that will be photovoltaic electric conversion, right? In this first case, in case of the thermal electrical conversion, we are just increasing the temperature, right? We are increasing the temperature of water or fluid, and that heat will be converted into mechanical energy, and that mechanical energy will be used for rotation of the turbine, and because that turbine will be further coupled with that some generator or alternator, so there d5 by dt will be produced, and that d5 by dt will cause for the production of the EMF. In the second case, in the case of photovoltaic cell, photovoltaic electrical conversion, so in this particular case, what will happen that with the help of solar radiation, some p-n junction is there, right? And that p-n junction is used for the conversion of solar radiation into electrical energy. Another is solar distillation, solar pumping, solar distillation, that means for the distillation of the water, then for as a solar pumping, then some agricultural application, right? Then after that, solar furnace, solar cooking, solar furnace, then solar cooking, right? So these are some applications of the solar energy which may be considered as direct energy application of the solar energy, right? In all that cases, we are using solar energy, and that solar energy may be convert that solar energy into the form of electrical energy. Now, in case of this solar furnace or solar furnace or solar heater, what will happen? That the solar energy is converted into the form of heat. Solar energy is converted into the form of heat, and that heat may be used for the production of the mechanical energy, and that mechanical energy will be converted into electrical energy. So there may be this indirect conversion into the electrical energy. So in case of the solar heater or solar furnace, radiations are converted into that thermal energy or heat energy, right? Further, this heat energy or thermal energy may be converted into mechanical energy and may be used for other purpose like cooking or some other specific application, right? But generally, the solar furnace or solar heating, solar furnace or solar heater, that will convert solar radiation, into that thermal energy, right? Now, what is photovoltaic cell? Photovoltaic cell is a simply solar cell that will convert solar radiation into the form of electrical energy. These are simply the p-n junction diode, which will be fabricated with the help of special type of material, right? We had already discussed this solar collector. Now there are two types of the solar collector, right? Then after that, there are two types of the solar collector, and that solar collector or solar collector or solar cell may be used to convert solar radiation into the form of electrical energy, right? Then there are two types of the solar cell, first of all, and then after that, one thing which is very important, that is application, that efficiency of the solar cell, is about 15% only, right? 15. Efficiency of the solar cell is about 15% only, right? So its efficiency is very low. Further, this some research is going on for increasing the efficiency or for the improvement of the process, so that more efficiency of the solar cell may be achieved. but in general, till date, we are only capable to achieve not even 25%, 15%, 15% of the efficiency when we are using solar cell, right? So there are two types of the solar cell, and second is efficiency of the solar cell is about 15%, right? So after that, I am just taking one application of the solar energy, that is solar furnace, right? So now before starting this solar furnace, I had told you two different things. One is that efficiency of the solar cell is only about 15%, right? Efficiency of the solar cell is only about 15%. That means it is very low. So research is just going on regarding improvement of the efficiency of the this solar cell. And second is there are two types of the solar cell, right? And then after that, this output voltage, as far as output voltage of the solar cell is concerned, output voltage of the solar cell is concerned, that will be only 0.5 volt. 0.5 volt. Under practical condition, this will be even less than this. But for as far as theoretical point of view, we are taking that as a 0.5 volt. So output voltage of the photovoltaic cell or solar cell, that will be equal to 0.5 volt only. So if we need more voltage, then accordingly we will have to connect that many number of the solar cells in series parallel combination, depending upon the requirement of the voltage or depending upon the requirement of the current. We will connect that solar cells into series parallel combination, right? So by the use of series parallel combination, we will be able to just make that 220 volt or 230 volt, which may be used for the that operation of the home appliances or some industrial appliances too, right? So what I am saying, that the output voltage of the solar cell is 0.5 volt, and if we want more voltage and more current, then we will have to connect these solar cells in series or in parallel combination to achieve the required specification, right? So that's why that solar panels are having that many number of the cells connected in series and parallel. These different combinations may be utilized for different values of the voltage as well as different values of the current, right? So as far as this solar furnace is concerned, the solar furnace is an instrument that is used to get high temperature by concentrating solar radiation on a specimen, right? So number of solar furnaces has been just situated, established, or you may say established in different countries to achieve different applications, right? So the world's largest solar furnace with a design thermal power of 1000 kilowatt, right? So here this world's largest solar furnace that will be designed for the thermal power of approximately 1000 kilowatt, right? And it consists of 63 heliostat, each having an area of 45 square meter, right? So if we are talking about principle of solar furnace, this is your concentrator, and here some heliostats are there, like this. These are heliostats, right? So here somewhere here it is a receiver, fine. So what will happen once that solar radiation that will be just fall here, heliostats are placed, here heliostats are placed, these are heliostats, radiations will be fall on the heliostat, and after falling on the heliostat it will be just reflect towards concentrator, like this. And if after this falling on the concentrator, it will be again reflected back, and this will be just collected at the receiver, right? Here from this side radiations will come, from this side radiation will come, when that radiations will be fall on the heliostat, and after a reflection they will move towards the concentrator, right? The principle of the solar furnace is number of heliostats are arranged in terrace on the sloping surface, so that regardless of the sun's position, they always reflect solar radiation in the same direction on a large that spherical or parabolic type reflecting collector made of many bridges, right? And the most desirable mirror, is that obtained by grinding and polishing the glass plate and cooling with suitable film, right? So here when these radiations will be collected on the receiver after reflection through this heliostat as well as through the concentrator. This will cause for the increase in the temperature of the body, right, or temperature of the solar furnace. That will be that high temperature of the solar furnace, that may be utilized for various application, right? So solar furnace, as far as the users is concerned, solar furnace is excellent use. Solar furnace is excellent mean for studying property of the ceramics at high temperature above the range of the ordinarily measured in laboratory, right? So here in some of this solar furnaces we are using this for the application of purification of a refractory by sublimation at high temperature, right, or direct temperature production or zirconia from zircon at alkali, that may be again just used in the application of solar furnace, right? Now, as far as advantages are concerned, it gives the extremely high temperature, it provides the rapid heating and cooling, right? Then proper desirable atmosphere can be provided to the specimen. Then in solar furnace, heating is carried out without any contamination, and temperature is easily controlled by changing the position of the material in the focus, right? So various property measurements are possible on an open specimen. These are some advantages of the solar furnace. As far as limitations are concerned, its use is limited to sunny days only and to 4 to 5 hours maximum, right? And in addition to that, one of the major limitation is its working time, right? Its working time is very less. That is only 4 to 5 hours a day, and that is again in the sunny days only, right? And the second application is second limitation is we are not capable to use it because it is having the high cost, right? Its cost is very high, so that's why we will not prefer to use solar furnaces when other types of the applications are available, right? So this is regarding the solar furnace, its application, its advantages and limitations. So this is the end of the lecture. We will meet in the next lecture again. Thank you.